Hello and welcome to Solidworks Live. Today we're streaming to you on live.solidworks.com, Facebook Live, YouTube, and new, we're going to be streaming on Instagram now. So welcome everybody who's tuning in for the first time on any one of those social media platforms, or if you've been joining us all along, welcome back. We have some exciting stuff we're going to go over here today. We wanted to use this morning's opportunity to talk a little bit about the simulation portfolio from SolidWorks and what some of the different tools that SolidWorks offers provides everyone. And to do this, I have three guests here with me. Kurt Anlicker from the product introduction team. I
Thanks, Jeremy.
myself am Jeremy Rigneris from the product introduction team. I should introduce myself. Michael Steves from the product introduction team. And with us today, we have Omar Zoni, who's a solution consultant and, shall I say, simulation guru.
You're too kind, way too kind.
Yeah. So, what we wanted to do is we wanted to take an opportunity and kind of not only look at some of the different tools we have, because there's a lot of them, but maybe some use cases and things like that. And I thought one of the great ways to start off was simulation means different things for different people. Some people use simulation to solve different problems. In fact, before we dive in and kind of answer this question ourselves, I'd encourage everybody, who's watching, engage with us on social media, in the comments, whether you're on YouTube, Facebook, or even on Twitter. What do you use simulation for, or what do you think simulation is most needed for in your organization? Likewise, if you have any questions, type those comments in there. We're going to have moderators answering those questions throughout this broadcast and even afterwards, because you can always come back and watch these videos later. But I want to pose this question here. Kurt, when you think about simulation, what is the thing that jumps into your mind that simulation is the right tool for?
Sure, Jeremy. So for me, simulation is, I just need to know, is what I've made going to work? Are my bolts going to fail? Are they going to work? Is my design going to bend too much? Is it going to break? Is it going to yield? Are my welds going to work? These kind of questions. This is what I need to know, whether or not that'll happen. So that's what simulation is for me.
Okay. Now, Omar, that sounds like a pretty typical use case of what I'd look at simulation for. What about you? What does it mean? What resonates to you?
Yeah, so Kurt brings up a real traditional approach to simulation. I like to think, one of the real benefits of having embedded solutions inside of CAD is the ability to run a lot of what-if analysis, right? So really optimizing your design, utilizing simulation and letting simulation kind of drive the direction of your product design, I think is a real powerful feature, especially for our tools.
So going beyond just does this work or doesn't it, but what's the best case scenario kind of
Yeah,
thing?
absolutely.
All right, and Michael.
Yeah, the first thing I think of is physical prototypes and being able to make that digital and do a lot more of this what if that Omar was talking about, and to kind of set up some experiments, figure out what's going to work, what's not going to work, to be able to think about how your customers are going to use your products that you've manufactured. Speaking of manufacturing, I think that's also the second part where what simulation means to me is being able to predict the manufacturability of parts and also optimizing the manufacturing cycle for how they get made.
Okay, so these are all slightly different views, and I think what we'll do here, why don't we run through a couple of those? So, Kurt, I want to start with you. One of the things you mentioned was I want to do some pass-fail scenarios. So,
Sure.
what do we mean when we look at that inside a SolidWorks simulation?
So we've got a quick example. It's fairly simple, but it's the kind of problem that most engineers are trying to solve. I've put some brackets together. I've welded it up. I'm not really concerned about the geometry so much and making it perfect. And SolidWorks Simulation does a great job of just taking care of things that aren't perfect in the geometry. And I want to see, is it going to work? Is it going to fail? What's my factor of safety? Is my part deflecting too much? Is it moving too much? And what about my welds? I've got a simple weld simulation on here to look at the weld beads, and it told me, hey, your two of these were too small or too not enough weld. You need to improve that, and actually gave me the suggestion, so I can just use that information, make a quick change to my design, run it again, and literally in just a few seconds, and get a thumbs up. This is gonna work. And obviously, there's more I can do later, but to get started, I just need to know, have I gone the right direction? Is this gonna work?
Okay.
So I've got another example. If you remember back in September, we had Omax in here, and Eric Beatty, and we talked a lot about the Omax water jet. So this is a much more complex example, but again, it's the same kind of situation. They're very concerned about the position, the deformation of where the head of that is, and that's controlled by this XY table. So when I look at that, I see, okay, this thing's barely moving, but it's joined on here by 16 bolts, 16 fasteners, bolts and nuts. Are those going to fail?
Okay.
Have I chosen the right size? Can I do anything different with that? Again, Solidworks Simulation automates all of this process for me, spits out the information I need, so it tells me I made a good choice, so I'm not getting a lot of deflection. My fasteners are all going to work. I have great confidence in what I've come up with, and I can keep moving forward on other elements of my design. So for me, that's that's kind of the crux of what I use simulation for a lot, is just solving that problem, getting what I need, and then being able to move on.
And you're kind of using this to help you iterate over your designs and make changes that you make assumptions of those changes from like what simulation gives us. So in the example, you had a weld that failed. You increase the size of the weld or change how that weld joins
Exactly.
together.
And the tool gave me a recommendation for what to do, and I just tried it out and it worked, and so I'm good to go. And that's, for me, that's the answers that I need. What do I need to do to make this work? And then maybe later I can come back and look at optimizing it. But first thing, I got to make it work.
Okay. And this feels like how a lot of engineers kind of go about their tasks. They continually are improving on your designs. But Omar, in the beginning, you had mentioned about using simulation right away from the beginning to optimize a design.
Yeah, I just want to piggyback on what Kurt said, though, because Kurt highlights some really powerful features, like doing weld analysis and doing like those virtual bolts are things that are really important to designers that as an analyst a lot of times you don't think about, right? And having those embedded, again, that's one of those things about having a simulation tool that's embedded in CAD and having a CAD company that understands how designers think. Like those two features could take a lot of time in a traditional FEA approach, and it's kind of push button with SolidWorks simulation. So yeah, they're awesome.
No, I love
examples.
how easy it is,
Yeah.
for sure.
Yeah, so I mean, an alternative approach, that's kind of a typical way or a more conventional way that simulation is used. I like to kind of think a little bit more broadly and more all-encompassing. So one of the things that we can do really, really well is take a design and kind of explore the design space. So if we take a look at this heatsink example, this actually came from a customer of ours in Southern California, and this was their initial design. So this is a heatsink for an LED device. They kind of knew how much heat was going to be produced and how heat was going to be dissipated off of the device. And they came to us, and this, again, their initial design, the maximum temperature was about 63 degrees. They said, hey, look, this can go all the way up to 76 degrees. So they knew it was over-designed. They couldn't change anything about the footprint, but anything related to the fins they could change. So we helped them set up kind of a design of experiment table where we took all of the variables associated with the fin. So the radius, the height of the fin, the number of fins, the thickness, and specified the range that those things could go over, with the goal being, keep the temperature under 76 degrees and minimize weight. And if you're making hundreds of thousands of these, that's important, right? So so SolidWorks simulation automatically sets up this design of experiment. We can walk through kind of each of the iterations that the DOE creates, the design of experiment, and it actually spits out the optimal design, right? And I like this example because a lot of times when you're looking at these kind of simulations, the initial doesn't look that different. In this case, the optimal design is about a 40% weight reduction. So then I think this kind of shows what the optimal design looks like. And, if you remember what the initial design was, it's quite different. Again, it's like a 40% weight reduction. You can see the temperature is much closer to 76 degrees now. So again, using a CAD package that's embedded, or a simulation package embedded in CAD, really allows you to do a lot of this kind of design exploration.
Well, especially with SolidWorks, making it easy. I think the thing that stands out to me here is being able to pick and choose those native SolidWorks features, sketch dimensions, pattern instances to be able to from drop lists. I mean, setting up those parameters is made very easy to set up that design of experiments.
Yeah, absolutely.
Yeah, I mean, there's like no other way to accomplish this other than leveraging the parametric features that are right there, right? I mean, I just don't know how this would be possible any other way.
Well, it's like, Omar, I mean, how long does setting up something like this take? From I have the initial CAD model, I made it in SolidWorks, from the initial design to the optimum design.
Yeah, I mean, so setting up the DOE and kind of figuring out the ranges for those variables, maybe it takes 30 minutes or 45 minutes, and then the running it's got to run each of those individually. That may take an hour to run those. I think there were 40 steps. It probably takes less than that, actually. But so within 2 hours, you're kind of getting an optimal design. Looking at temperature, and this is just looking at temperature. Obviously, if you had stress risk constraints or frequency constraints, you could couple all those together and do kind of a multi-parameter optimization. It's a really powerful way to utilize simulation.
Okay. So we've seen an example where we can get a yes, no, a pass, fail scenario. We're looking at optimization, leveraging existing features that exist there or a starting point. What if we don't really have any of that stuff? I mean, optimization, I love where you're going with this, Omar, but say I don't even know what this initial shape looks like.
Yeah, so this is where SolidWorks Simulation has a very powerful solution to give us this. And think about those parameters and having those in mind. But let's take a look at an example where the only things that we really know are kind of the boundary conditions. Where is this thing going to mount? Where are we holding it in space? What are the fixtures? And then what's the loading scenario? The other thing to keep in mind here is, well, what are the bounds of the geometry? Where do we want the material to be? But we don't know the exact shape it's going to be. So this is where with topology studies, we can create this optimum shape, and we can play around with the mass and kind of visualize, if we take material away or add more material, where is it adding? What does the shape look like? So SolidWorks, again, makes this very easy to set up using the same kind of studies that we've talked about already. It's integrated with the CAD so that when I'm ready to start, exporting this information to get it made, I can actually export the results right from here, for instance, for 3D printing. Or if we need to get more detailed on the CAD side, we definitely can. And being able to slice that mesh up, create some native SolidWorks features to create a fully detailed model. So if we're going to casting or wherever it may be. And then, of course, to get the warm fuzzies, if you will, of being confident in your design with that shape created inside SolidWorks, we can run one more simulation study, get the stress, get the displacement, make sure we're where we want to be.
So 3 really different ways to leverage simulation when we think about creating parts, checking parts, determining if they're going to be in those right places. And all of these examples, though, they've been fairly straightforward. They're materials we're probably all familiar with, steels, things like that. And we're looking at minor deflections. But one of the things we always hear when we use the word simulation, we always hear this term nonlinear, right, Omar? Explain to the folks who might be new to simulation what nonlinear is and why we might need to use that.
Right. So there are different classifications of nonlinear. I'd say the bulk of it typically refers to having like a material that behaves nonlinearly. So a rubber material is a real common example. If you're looking at metals, like how they behave beyond yield, so when they're going to have some permanent deformation. And then kind of a more complicated example is when you've got things that are coming into and out of contact. That can be real, that can throw a wrench in a lot of simulations, and those are typical cases where you'd have to run a nonlinear simulation. So I think we've got a good example here of kind of a rubber sealing analysis. So in this case, again, this is an example I like to show quite a bit. It's got 2 rubber seals kind of in the center. It's axisymmetric, which means you can model it in 2D, which can save you a lot of time when you're running these types of simulations. We're utilizing a hyperelastic material model, which is typically how rubbers are represented or characterized in simulation. We can enter in like the test data. SolidWorks simulation will automatically characterize the rubber if you've got your test data. And kind of one of the more complicated things you've got to do when you're running an analysis like this in SolidWorks is, well, actually in most FEA tools, is you've got to kind of define the contact pairs. So as this thing is going through its range of motion, what faces are going to come into contact with each other. And you can see in this example, it's a lot of deflection. The rubber seals are actually kind of compressing on themselves. So Yeah, a nice thing that you can do in SolidWorks simulation is even though we're running in 2D, you can kind of show the results in 3D. So I've
Makes it
worked, yeah,
makes it really easy to
right,
visualize
yeah.
3D. Yeah.
Yeah, and if you've got a boss who doesn't understand 2D analysis, this is a great way to kind of not have to explain it. I've worked in industry before and had those types of bosses, not now, but yeah, so I like this example. It's a really cool example. But again, kind of the pain in this thing is setting up those contact pairs because you don't know a lot of times um, what parts are going to be coming into contact with each other. So, um, one of the really exciting things that's going on in Dassault and specifically kind of with SolidWorks and in the simulation space is we're starting to collaborate with another brand inside of Dassault called Simulia. And Simulia develops the Abacus Solver. It's one of the things that they develop. So the Abacus Solver is a finite element analysis solver on the mechanical side that's kind of world renowned as probably the best in class solver out there. And we're going to have a new kind of tool set created with them called Solidworks that's going to leverage our SolidWorks CAD, even our SolidWorks simulation if we want, and the Abacus Solver. And the Abacus Solver really provides us a lot of cool technology that we didn't have inside a simulation. So here's an example of a foam brick that's going to be compressed. The first thing that you'll notice is, now with Abacus, we've got the ability to do brick meshing. We also have a whole range of material models that weren't available inside of SolidWorks. One of the real benefits, though, is the way they handle contact. So in SolidWorks simulation, where you had to kind of define what faces or edges that were going to be coming in contact, they make the assumption that anything could potentially come into contact. So you don't have to set up really any contact pairs. A model like this, not as big of a time saving, but if you think of like more complicated, like honeycomb structures,
Like my machine.
yeah, right. Or even the example that we showed earlier with the rubber seals collapsing, like you just wouldn't have to set up those contact pairs. It's a real time saving, and that's like one of the real pains in finite element analysis, especially on the nonlinear side, is setting up those contact pairs. So yeah, it's a really exciting time.
For those of you watching, I mean, taking a look at this example, you notice that we're not inside SolidWorks. We're actually leveraging the 3D Experience platform, which is automating the connection between these multiple tools and applications and apps, right?
Yeah. Yeah, so the 3D Experience platform is obviously the new collaborative platform available with the SO systems, and it's where you're going to be seeing a lot of these new tools are going to be added to that platform. It's an exciting time. So this is a product. Oh,
I'd like to actually interrupt you right there. You're bringing up a really interesting point. And so for folks who are new, who maybe don't watch SolidWorks live regularly, we actually did a piece on the 3D Experience platform. We had some folks you work with, Jordan and Todd. We came in and talked about some things we did. We also had Devin on there, and he provided some really good insight as to how SolidWorks and our channels really going to start being able to take advantage of the 3D Experience platform and some of these other brands that, Dassault is a huge R&D organization. And this afternoon, I encourage everybody to tune in. We're going to be talking about data management there. We'll be seeing SolidWorks data management tools on the platform. But we're going to see this throughout all the different brands inside of Dassault Systems, and there's even more stuff coming from Simulia, right?
yeah, as a simulation nerd, this is like a really, really cool time to be involved in SolidWorks simulation because we're really starting to collaborate quite a bit with the Simulia guys. So again, this product is available now. The one that we're showing now uses the Abacus Explicit Solver, and this is coming in Q1 of next year. So, for things like crashes and like this can crush analysis, this is stuff that you couldn't have done with SolidWorks simulation, right? No matter how much you tweak the solver, this is just beyond the scope of what it could do. Yeah, and just another great use case and another, great product that's going to be available in Q1. And, if you look at kind of some Abacus is just one of the tools available in that Simulia brand. They have tools for electromagnetics and some really complicated flow stuff. They have acoustics, and the topology optimization that Michael showed earlier actually came from Simulia also. It's using their Tosca solver. So yeah, it's a really exciting time, and I couldn't be happier to be in the Simulia or in the simulation space right now with SolidWorks. So.
Yeah, I think that's across a lot of the different workflows and things that people are doing with engineering. They're seeing these opportunities to leverage some of these other tools.
Yeah.
So, You know, a lot of the examples we've looked at, they're what I think people look at when they think of simulation, where exerting a force or exerting a load on something like that in an environment of how something is built. But one of the things that comes to mind is, what about like the real world and kind of how the world around these components interacts with these parts?
Yeah, let's
What do
talk
we?
about that a little bit because you should be mindful of, not only how your product is intended to be used, but where and what other environmental factors should you consider. For instance, if your product is going to be mounted in a car, there's a lot of vibration that can happen, and how is that going to impact the performance of your product that you're designing? So, I mean, if it's vibration, if it's periodic, or if it's random vibration, these are types of problems that we can solve and visualize inside SolidWorks simulation. So again, think about some of the physical testing that you may have to do on, like, taking a look at this PCB. In the physical testing, you may have a shaker table. You put some accelerometers out to understand how this component is going to respond, how it's going to perform. And many times, taking a look to solve this, you're running that shaker table for a long time to take a look at, fatigue. What's the actual life of this going to be? So again, we can do this virtually with SolidWorks simulation, setting up again what we know where the fixtures are going to be, and we can actually put in virtual accelerometers, if you will, to visualize the response and be confident in our design. SolidWorks is always improving the collaboration between electrical design, PCB designers, and mechanical. And we see that we've actually talked about that on our previous SolidWorks Live events for SolidWorks for electrical engineers. But taking a look at what we can do here with the simulation integrated on mechanical and being able to do this early, we can make more informed decisions on the placement of some of these electrical components and collaborate with the PCB designer with much more informed decisions.
I like what you had mentioned. You had talked about this early on with virtual testing and relating this to kind of that shaker table example here. And you mentioned the time. I think we've seen examples of this where people will have to test a component like this for weeks,
Yeah, I mean,
days,
right.
and they're getting results from this. You had also mentioned fatigue, right? I think I've heard you've mentioned something, Omar, about like checking to see if solder joints will fail.
Yeah, so one of the interesting things that for components like this, a lot of times you're interested in, how many cycles the joint between the actual component and the board can withstand, how many, cycles, whether it's random vibration, the time in a random vibration sweep or the number of cycles in a harmonic response. And you can do those types of fatigue analyses. I think a couple of releases ago, we introduced that capability. So yeah, I mean, it's an important thing to look at, right? The more real world aspects you can take a look at virtually, the better your designs are going to be in the long run. So it's just an added complexity and something that's pretty easy to set up, but powerful, powerful.
So we saw an example of a circuit board here. I think one of the things that comes to my mind, and a lot of folks, yeah, everyone has a phone in their pocket, heat, right? Like, what do we do with that? Are we doing anything to like look at how heat affects the components around them?
Yeah, in fact, it's a favorite tool of mine is our flow simulation tool. So in this case, you can obviously do the board itself, or you can take the entire package and look at electronics, cooling, or multiple electronics and power supplies and all this, like the example we'll show here, and see how the entire system is being cooled. So this example, I've got an electronics box. We're all familiar with them. They come in all shapes and sizes, and this one is actually, the box is acting as a heat exchanger. So there's water running across the outside. How much heat is getting out of the system into the water, and how much is staying in? Are there hot spots? Are there places that I'm just not getting the cooling that I need, and I have to worry about about my electronics or anything overheating? So flow simulation is just a great tool to see that. Very, very visual tool, obviously. I can see that information. I can make decisions on how I package thing up, how I get the heat out of that system. We think about it. We all have a laptop, that it's got hot spots on it. You're wearing anything like that. You've got to figure out how to get the heat out and not affect the user or not affect the maintenance or whatever of that system. So
Flow simulation makes it easy to visualize. Obviously, where is the heat?
Exactly.
beautiful images that you can create
Yeah.
about that to visualize that. But I'd encourage you to take a look at when some additional functionality was added with SolidWorks Flow Simulation in 2019, last
Yeah.
year. And not only, of course, we've been able to visualize, some of the heat maps and kind of things on the physical product itself in 3D, but we can actually take a look at, what's the heat path and actually what are the numbers. So like in your case, Kurt, how much heat is going into that enclosure and then what's going to the water surrounding it.
Yeah.
Flow simulation makes it easy to visualize that data.
So, I mean, it's interesting because when I hear flow, heat wasn't always the first thing that came to my mind. I always think of kind of like aerodynamics or wind tunnel testing, stuff like that.
Sure.
And are we doing that with SolidWorks Flow as well? Are we able to like see how? So here you're showing kind of the convection of the heat, but what about like applying a load on something with kind of, you mentioned water going around it or wind blowing on something?
Yeah, so our flow simulation tool is general purpose, so that's something that we can do pretty easily. It's easy to set up like a virtual wind tunnel. So I think the example here is just it's a solar panel basically, and we can take a look at I forget exactly the wind speed. I think it's 70 miles per hour. I think it's a pretty big gust of wind, but we can look at the wind flow around the solar panel. You can also look at the pressures that wind is creating on the panels, and then run a structural analysis based on that pressure loading, right? So to make sure that your solar panels aren't going to deflect too much.
Yeah, that's the thing I like the most is you can run the flow simulation, you can get your pressures and forces, and you can get your temperatures and bring that back into SolidWorks simulation to run static and thermal, stress studies, and you have better input to to drive that output. So
Yeah, I mean, you're literally generating the loads for your static study
Exactly.
based on this flow study.
Yeah, and you can do the same thing with thermal, like Kurt said that
Exactly,
he just ran. And thermal is becoming such an issue, right? Because we're miniaturizing devices so much, and there's so much power inside those small devices. So, yeah, I'm with you guys. The flow tool is one of my favorites, also.
Yeah.
Visually, it's always cool to
Yeah.
kind of see the results from there. So we've looked at performing simulations on parts, seeing how they perform under those conditions. We've gotten an opportunity to see some real world conditions, but before these parts are even made, I mean, manufacturing comes to my mind. Can we do anything to look at the manufacturing processes and how we can improve those with simulation tools?
Yeah,
I mean, flow, right?
Yeah, let's talk about plastic parts because it often made with plastic injection molding specifically. And I get the question a lot with like flow simulation. It's like, can I use that to predict how well my part's going to be manufactured with plastic injection molding? No, we've got a different tool to accurately describe and predict the manufacturability of parts. But taking a look at that, entire process. So this goes beyond just for part designers, but all the way up to mold makers, mold designers. But the story I always like to tell here is I was working with some part designers, so some plastic injection molded parts. They went out, they had someone else make them, they got them back, they did their physical prototype, and those plastic parts were the immediate point of failure. It's like, well, why was that? Well, because the load path going through those parts was right along the knit line. So with how these plastic parts are made, depending on how the plastic can flow, it's important to realize and understand where those knit lines may be. And we have an example here to take a look at so that we can visualize, how the plastic is coming in to fill up that part and where these knit lines are going to be. So we can visualize where those kind of weak areas in the part are. And also change, so we can actually have, we have control. We can play around with some of these different possibilities of where's the plastic coming from when we manufacture this part. So from a part designer, I can make more informed decisions when I go out and start working with some of these mold makers to say, here's where I think some of these injection locations should be, and here's why, because we want to avoid, those weak areas in the model at specific locations. But it goes beyond, that part design mentality. We can start to take a look at, the entire manufacturing process. And this gets into, some of the, for the mold makers, mold designers, because I can go beyond just the filling. I can look at the pack and the cooling to take a look at that entire cycle time. I think, Omar, we can also take a look at some of the warping that happens, right?
Yeah, you can actually. With plastic injection molded parts, you get this phenomenon called residual stresses, and the parts generally come out warped. And typically not as you intended. So you can actually print out or you can send the warped shape into SolidWorks as a part file. And then you could actually print that part out with a 3D printer to get a feel for like the fit, form, and function. Or you could go back to SolidWorks and kind of try to build in for some of that displacement so that your as manufactured plastic injection molded part meets your initial design criteria. There's so much you can do with these tools.
I always find plastics to be super interesting because you're not only performing simulation and evaluating the performance of the mold tool itself, but you're using that information to then iterate on the part and perform simulations on that part. And it's that back and forth coming up with that perfect design that's both going to meet the demands of the application, but also provide the best performance in the manufacturing environment as well.
Yeah.
I think so. It's really powerful, I think, for optimizing the overall process here is we're doing things like digital virtual quality checks, right?
Yeah.
And also taking a look at like for the entire cycle time and what changes can you make to either the part or the mold to really optimize that entire cycle time. So this gets into a little bit of a bigger picture here,
Sure.
talking about manufacturing because we're kind of optimizing what's going on in that entire manufacturing chain. So this is where, I mean, we talked a little bit about 3D Experience earlier and that platform and the suite of tools that we have available to us. You know, one of those is Works, and we talked about this in the last live event that we had. And we're going to actually dive deeper into that coming up on December 4th.
That's correct.
Right?
Yep. That's going to be our next. Well, this afternoon we have a SolidWorks live episode, and then December 4th we're going to be having one as well for Works, where we'll be discussing that.
Yeah, and this is kind of the whole manufacturing supply chain. Material coming in the door, going out for quality products. How are you doing those quality checks, making sure the machines are running, and you know, applying some of the virtual testing that we did earlier.
Sure. Yeah, I think this was a really good, insightful look at a lot of the simulation tools we have here. I mean, we started out from the very beginning. Simulation can mean different things to different people and what their goals and objectives are out of that. I mean, if we were to walk away with a takeaway, I mean, Kurt, when you look at all the tools that SolidWorks Simulation brings to the table, I mean, what are the big takeaways that you want the folks watching at home to really understand when they see all these different tools and capabilities?
For me, Jeremy, it's about the power and the ease of use. You know, there are core design questions that I think most of our users face probably daily or weekly that they need an answer to. And SolidWorks Simulation makes it super easy to get that information, to make good decisions, to drive your design down a good path. That ease of use to answer those questions, for me, is the great thing. You don't have to be an expert. You don't have to have perfect geometry. Simulation takes care of so many things for you to get you the answers you need.
All right. Omar, I mean, same thing. You've been using the simulation tools for a long time. I mean, when you have customers approach you for the first time and they're curious, I mean, what are some of the takeaways you want them to understand about these tools?
Yeah, so I mean, for me, it's really that embedded nature to the CAD model, right? Because we know how passionate the SolidWorks user community is. I mean, the tools themselves feel like SolidWorks. They're really easy and intuitive to get up to speed with. And there's just so much power and I just think the SolidWorks DNA put on some of those simulation tools, it just opens a whole toolbox for designers to really optimize and be real innovative with the tools.
Cool. Michael, how about you? I mean, you've been using simulation for years. You had some really cool YouTube videos back in the day.
Yeah, I mean, from pool trick shots to to visualizing how fast a cup is going to fill up with water. I mean, that's one of the things I really like doing with SolidWorks Simulation is, and just SolidWorks in general, is taking a look at the world around us and better understanding some of the physical phenomena that go on, understanding some of the physics, and being able to share that information with others, if that's to improve your design or to have a little bit of fun too.
Yeah, I mentioned it briefly a little bit ago, especially with SolidWorks Plastics. I love that optimization of like trying to find that perfect mix of like the right part meeting the demands with a high performance manufacturing I love that, being able to, you said it from within that environment, within that single environment, it's really easy to tweak and make changes and see how those will impact the performance of those components. So. I want to thank everybody for being here today. I hope this was insightful for everybody at home, kind of get an understanding of a lot of what we can do with the simulation tools for SolidWorks simulation. This was fun for us to kind of like walk through and look at some of these examples that we go through here. But we're not done. We have more SolidWorks Live coming up. So this afternoon at 1 p.m. Eastern Time, we're going to be looking at product data management and kind of what those tools are on the available through the SolidWorks portfolio for managing your data. We appreciate everybody who tuned in live today, whether that's on Facebook or YouTube, and all of our new followers on Instagram that joined us live. So keep in mind, we're going to be doing live events both this afternoon. December 4th, we're going to be having one come up. We're going to be talking about Delmia Works, and we're not far around the corner from 3D Experience Worlds, where that's always a big highlight, where we do a lot of live broadcasting from there as well.
Exactly.
So until this afternoon, we hope to see you later on this afternoon. Thanks for joining us today, and we'll see you soon.